In this section, we are going to dive into the world of object-oriented programming, or OOP for short. So what is object-oriented programming? Well, we can think of it as a method that a developer can utilize to structure a program more efficiently. Now, it allows us to group related properties and behaviors into individual objects. Now, this may sound confusing, and was to me when it was verbally explained, so let's think of a simple example to highlight what I mean. Imagine I asked you to create a data structure that needs to store information about a dog. For example, we know dogs are a type of breed, so we may want to store what type of breed they are. They would have a name, and they would also have an age. Now, these are known as properties, as they tell us something about the particular object, in this case, a dog. Other properties could be owner's name, favourite toy, or weight. So you may decide to create a list with the first item containing the name of the dog, the second containing the age, the third may be the breed, and so on. Now, dogs don't just have properties. They also do stuff. They perform actions. For example, they eat, they bark, they run, and they sleep. And we've also seen that creating functions allows us to create and call specific actions. Now, let's suppose you start your own dog care centre where people can drop their dogs off for the day so that they're not left at home whilst you go to work. You may have the need to store information about 20 dogs at any one time. Now, how would you currently think about storing this information? Well, so far, we have discussed data structures like numbers, strings, lists, dictionaries, and these are all designed to represent simple pieces of information. So we may do something like this. Our first customer is a dog called Bruno, so we may set a variable called Bruno and set this equal to a list where the first item in the list is the name Bruno. We can put a comma and the second item relates to Bruno's age, so we'll put 3. And the third item can be Bruno's breed, so we'll put poodle. Now, if we had a second customer and we wanted to create information pertaining to a second dog, we could do something similar. So let's create one called Dolly, and we'll set this equal to a list where we'll put the first item as Dolly's name, and the second item stating that Dolly is a lab. And finally, we'll set a variable called Flo, and in the list, we will have Flo. Flo can be 7, and Flo can be a pug. Now, if we really think about this, is this the best way that we can store this information on a computer? For example, how would we access this data? Is it consistent for all objects that we've created? Well, in short, there are a number of issues with this approach. Firstly, imagine you had a really large code file. If you reference Bruno and pass in index 0, 10,000 lines after it was originally defined, how would you know what you're accessing? Would you remember that the element with index 0 for this object represents the name of the dog? Maybe, but if you're like me, probably not. Secondly, it can introduce errors if there are not the same amount of elements in the data structure. For example, accessing index 1 represents the age for both Bruno and Flo, but not for Dolly. 1 represents the breed, so this could cause problems. Now, a great way to make this type of code more manageable and more maintainable is to use what are known as classes. Now, classes are what we use to create user-defined data structures. Now, in the above example, we could create a class called dog, which helps us handle all of the information related to a dog, such as storing their name, age, and breed. So properties, i.e. they tell us information about the dog, as well as behaviors such as eating, sleeping, and barking, which could be functions that we define in the class, and these are also known as methods. They really help us manage complex structures more easily and make programs a lot more elegant and scalable, and this will become apparent throughout this section. So to summarize, OOP allows us to model real-world subject matter and convert them into software objects. And these software objects have data associated with them, so properties, as well as having the ability to do stuff, i.e. they have functions they can perform. So far, we have mainly focused on procedural programming, which structures a program in a set of steps, in the form of functions and code blocks, which when we call in a specific order, will complete a task. And in doing this, we created objects that were used in different parts of our code. We are now going to see how we can create user-defined objects to help us better structure our programs.